19 of Neetcode 150 minimum window substring. In this problem, we're going to be given two strings. The first one is going to be longer than the second one. And we want to have basically a substring within the string S that includes all the characters from string T. And this has to be, the substring has to be as small as possible. So for example, here we can see that in the example 1, we have Y, X, A, and Z, which is this sequence here. And this is the shortest sequence that includes T basically, so all the characters X, Y, and Z from T. Okay, so for this problem, we are going to use a sliding window technique. So this is our window right now. It is currently pointing at the index 0. We are also going to set an expected value, which is basically going to be the length of the hash map of the count of the substring T. You'll see later why this is needed. The problem asks us to render basically the sequence of the substring, so we are going to have to keep track of the indexes of the shortest substring so we can render it at the end. And we are also going to have to keep track of the minimum length. Since every time we are going to make our check in our loops, our check is going to be is the new substring smaller than the previous minimum length. Okay, so what we need at first is to have like the biggest possible value for the min length. It's infinity, so we know that the second one is for sure going to be smaller than our initial infinity value. So in the problem that I'm showing you right now at the screen, our string S is the following here, and our string T is NSQ. Okay, so the first thing that we want to do is to basically create a hash map of the count of T. So we will go through every single characters of T, and we're going to add them as the keys, and we are going to add their respective frequency in T. So right now we have S, which appears once, we have S, which appears once, and we have Q, which appears once as well. And once we have this set up, we are actually ready to start moving forward. So we can see that the first index in the window, it's basically F. And F is actually not in the count of T, but still we are going to add it in the window. But I'm going to add it to the right just because it is not really important in our case, but it is still here. So I'm going to add it to the right. Okay, so after this, we want to check if the new value that we had is basically inside the count of T. In our case, no, it is not. Right. So if we had found a Q, for example, and now in our window we have a Q of 1, well, we can see that our current is now 1. Okay, I call it current. You can call it half. You can call it equals, or whatever makes more sense to you. But basically, it represents like how many value in the windows are exactly the same as those in the count of T. Right now we are still at 0, and we basically expect 3, right? So we expect to have an N of 1, we expect to have a S of 1, and a Q of 1. So this is 3, right? 1, 2, and 3. Okay. So since we don't fulfill this requirement, we are going to move the window by 1 to the right. So now we include G. So we're going to add it to our window, which is a hash map. All right, it is here. But still, it is not in the count of T. So we are not fulfilling the requirement that the value in the window is the same as the one in the count of T. So we are going to keep moving our windows. Okay, if I can actually move this black pen. Okay, so now we have a S, and actually S is within the count of T, so I'm gonna add it here. So um, S1. All right, and this is where we check is basically the new character that we had um, in the count of T, and is its value, right? The value 1, is it the same as the value of that same character in the count of T? In this case, yeah, both S are 1, so we are gonna add our current by 1. So we have one of the three requirements fulfilled um, for this problem, okay? But not all of them are required, so not all of them are fulfilled. So we still have to move our window by 1 to the right. And now we have W. Again, it's not in the count of T, so we are just gonna add it to our hash map without doing much more than that. We're gonna keep moving. We have our L. Is L really important here? No, we don't really care. So we're gonna keep moving. And now we arrive to a point where we actually have a character that we care about, the Q. Okay, so we are gonna add our Q in our window. Great. And now we can see that the windows in the county both have Q, and the second check is, are their values the same? So Q in county is 1, and Q in window is also 1. Since this is true, we are going to add 1 to current. And after this, we are going to keep moving by 1 our windows to the right, and we add an N, which actually fulfills the last requirement. So we add an N, and we are going to increase our current by 1. Okay. And now what we wanna check is the length of that substring that contains all the characters of T actually smaller than the previous minimum length? Well, right now the previous minimum length is infinity, so of course it is smaller. So this is what we are gonna do next, is update the minimum length between the minimum value between the current string and the minimum length. So right now we have a substring of 1, 2, 3, 4, 5, 6, and 7. So the min length is no longer infinity, it is 7. And we also want to update our indexes. So our indexes are starting from 0 to 6. And the logic is that if this appears to be the smallest substring containing all the values of T in string of S, well, we are going to return basically the substring of S from index 0 to index 6. Okay. Yeah, actually it's index 7 because it is bound. So no, anyway, okay, so now what are we doing? We have a substring containing all the characters of T, but I mean, it doesn't mean that this is the shortest substring that we can have in our string S, which contains all the characters of T, right? So we are going to have to find a way to actually keep moving forward and check if there's another solution. So what we're going to do is that we're going to check basically if by moving the windows to the right, we are still having a current count of 3. So we are going to remove F because it is the value that is no longer going to be in the window once we move it to the right, just like this. And it appears that yes, we are still fulfilling the 3 requirements here. So the current is still the same value as the expected one. So we are going to keep moving like this. We are going to remove our G to realize that we are still meeting the requirements. And every time that we remove the left value, we have to also update the minimum length. So I didn't do it for the last round, but right now we can see that we have a substring of 1, 2, 3, 4, and 5. So the minimum length is now 5. And we are actually starting at index 2 now. Okay, so great. Um, Now we are gonna remove the left index because we are still meeting the expected value. But oh, what happens is that um, we're no longer meeting the requirements where the value of s in the window is greater or equals to the value of s in the count of t. Um, so at this point, we are gonna um, return in our initial loop of moving the right pointer to the right. Okay, so we are gonna do exactly this, but before we just have to decrement the current by 1, and we're gonna move to the right. We have a w. Okay, so now we have 2w. I'm just gonna put a 2 here to be lazy, but we're still not meeting the expected value. So we are we're still gonna move to the right, and now we're gonna add our s, and this is the moment where we are incrementing our current by 1. So we are again meeting the expected value, and at this point we are also gonna move the right pointer to the right and decrement the value of the character that is no longer in the window, so w, and we see that we still meet the requirements, but we have a length of 5, so it is not shorter than our min length. So we're just going to keep going. We are going to remove L, basically. Okay. We are removing L, and we are still meeting the requirements, right? And the length of this substring is 4. So now we found something that is actually shorter than the previous answer. So we're going to add 1, 2. Okay, so we're also going to update the indexes. Just like this. Okay. And after this, by removing the Q, well, we notice that we are no longer in the requirement. So the current is going to be decremented by 1. And I don't need to finish the rest of the string here. We have our indexes and our min length. So we are basically going to return s, right, at these indexes. So this is what we are going to return. Oh, and this is going to give us basically the Q and W and S. All right. So now we are ready to actually code this. This is going to be the most challenging part. First of all, we have to account for a hedge case where the T string is actually empty. So what do we do if basically T is empty? Well, we are going to return a empty string. Okay, and now this is where we have to create our count T and our window. So yeah, okay, so count T and window, they are our hash maps. Okay, and now we want to set the count of T for once, and after this we are no longer going to move or touch the count of T as you saw in the example, because this is going to be our reference. So for basically C in T, sorry, not count. So for the C, basically in the string T, all the characters in T, we are gonna add the key, which is gonna be the character, and this is gonna be basically equal to 1 plus. Now we have to find whether there is actually a value at that key or there is no value. So what we are going to do is that we're going to say basically get the value at the index C, otherwise return 0. So this is going to accommodate both cases where first count of the character is not in count of t, and also the case where it is already in. Okay, so great. Now we have our count of t. So we are ready to create our current. And also, as we saw here, so we're going to create our current and our expected. And the current is basically going to be 0. And our expected is going to be the length of the hash map count t, because this is going to remove the duplicates, if any. And after this, what do we have to create is our indexes and our min length. So let's set the indexes to something out of reach for now. And also we are gonna set our min length to the infinity. So we have to use float in Python. Okay. Great. And now we are ready to jump into the actual logic of the algorithm. So we are gonna set our left pointer to 0 at first, and now we have to create a logic where the right index is moving forward until basically all our currents, or basically when until the count of current is equal to the count of expected. Okay, so we're gonna create our for loop. So for r in the range of the length of s, well, we are gonna add in the window that value. So window sr, just like this. It's gonna be equal to 1 plus window dot get, right? Otherwise 0. Great. And now this is the time where we want to check basically is the value of the string at the index r in the count of t, and if yes, does it have the same count as the that same value in the window? Okay, so we're gonna write if sr in count t and window of sr is equal to, right, so okay, if they appears to be equal, we are gonna increment our current by 1. This is the first if statement we want to have. And now what do we do in the case where our current is equal to our expected? We want to check if the length of that substring that we have is actually smaller than the previous minimum length. And then if it is the case, we want to set the indexes to the current indexes. And to do so, we will create a while loop. So while the current is equal to the expected, well, this is true if the basically the length of the substring, so right index minus the left index plus 1. So if this is shorter than the min length, Well, we are gonna set the indexes to the current indexes. So indexes are gonna be equal to the left index and the right index. And the min length is gonna be equal to the length of the current substring. So the right index minus the left index plus 1. Okay. And then we will remove from the windows that index from the left. So window, we're not going to remove it, but we're going to decrement its count by 1. So just like this. Okay. And then we are going to check basically if that value that we remove is still in the count of t. And if by doing so, that value in the window is lesser than that value in the count of t. So first, if that value at index L is in the count t, and also the window at the left index, right, is now smaller than that same character in the count of t. Okay, well, it must mean that we or current no longer holds, right? We remove a value that we needed to have our requirements fulfill for the current. So current is going to be decremented by 1. And then at the end of the loop, we want to, at the end of that while loop, we want to move our left pointer to the right. Okay, so this might going to break this while loop. Okay, and at the end, basically, at the end of the for loop, we're going to set our left index and our right index to the indexes. And we want to return basically the string from the index of the left index, basically until the right index. So our bound will be the right index plus 1, just like this. And also we have to make sure that the minimum length is no longer infinity. So if it is infinity, we are gonna be willing to just provide an empty string, because this is a case that might gonna happen where there is no solution. So if basically the min length, so if the min length is not equal to infinity, or in the other case, you want to return an empty string, just like this. Okay. So we get an error here, if type. What is the, I apologize. We are gonna have to indent everything. Okay, so let's run this. And there you go. This is minimum window substring. And basically we solve this problem with a time complexity O of n, right? And the space complexity, since we had to create hash maps, well, we have a space complexity of O of m. I hope you learned in this video, and I hope to see you in the next one.